complex numbers. Z1 is given as 1 plus bi, and Z2 is given as 1 minus b square minus 2bi. There are two complex numbers. Find an expression for Z1 times Z2 in terms of b. So for part A, all we just need to do is, so if I talk about Z1 times Z2, so that's going to be just 1 plus bi times 1 minus b square minus 2bi. I just need to expand this with a normal basic algebraic rules. So 1 times this and this into this, then again this into this and this into this. So it's going to be 1 times 1 minus b square, then minus 1 times 2bi has to be just 2bi, then plus bi times 1 minus b square, and bi times this one has to be minus 2b square and I square. This is what I'll be having it. And we should know this, the value of I square is going to be just minus 1. And if I expand this one, this is going to be 1 minus b square, then minus 2bi, then this is going to be plus bi, then this is going to be minus b cubed I. Then this is going to be minus I square is minus 1. So that's why you can just replace that with positive 2b square. And whenever you have these types of expressions, always simplify it and keep the real parts and imaginary parts separately. And here we can simplify these two parts. At the same time, we can also simplify these two. So when I do that, I'll be getting 1 plus b square for the real part. And here it's just going to be negative bi. And if I take out I common out, so it's going to be negative b cubed. And this is what would be equals to I. And this is what we have it. And this is the right answer for part A. And the 3 marks distribution goes something like this. So 1 mark is for showing up the expansion. 1 mark is for showing up this expansion, and the second mark is second and the third mark is for the final answer. You're getting the real part correct, so this would carry 1 mark, and getting the imaginary part correct, so that would carry 1 more mark. So that's how the 2 marks are distributed. That's how the 3 marks are distributed for this one. And for part B, hence given that the argument of this Z1 times Z2 is given as pi by 4, and we need to find the value of b. So whenever I talk about argument of any complex number, it's basically, so whenever we have it something like x plus iy, so argument of this complex number, if I consider taking this as z, argument of this complex number is going to be equals to tan inverse of y by x. So keeping that thing in logic, so argument of Z1 and Z2. So this is the real part and this is the imaginary part. So it's going to be tan inverse of, in place of y, we have negative b cubed divided by 1 plus b square. And this is what is equals to pi by 4. I can take this tan inverse to the other side. When tan inverse goes to the other side, it will just become tan of pi by 4. And on the left-hand side, I can take negative b common out. If I take negative b common out, so I'll be left with 1 plus b square divided by 1 plus b square. And here 1 plus 1 plus b square and 1 plus b square, we can cancel it out. And tan of pi by 4 is just 1. So that's why the value of b is negative 1. And the 3 marks distribution goes something like this. So 1 mark is for showing up this step. And the second mark is for doing all the simplification. And the third mark is for the final answer. So that's how the 3 marks are distributed for part B.